Hi, my name is Matt Locke here with Proximity Labs, and today I'm going to be describing the based agent stack. Based agents have two main components. One is the worker agent, which runs inside a trusted execution environment, also known as a T, and a smart contract, which runs on the near blockchain and basically gives us access to a lot of things like near intents and multi-chain signatures so we can perform actions on any chain. Inside the worker agent, which we're going to deploy right now, we're going to derive a near account that's specific to this instance of the worker agent running in the T. We're going to get an attestation, and we're not going to show this, but basically your worker agent would have some stateless actions, which would basically encapsulate how it interacts with LLMs and inference, and basically any off-chain APIs, compute, and storage. So you could think of these as like the deterministic or stochastic rules that are verifiable because they're running inside the T, and we'll show you how that's verified. The code base is verified in the smart contract in just a moment. But let's go ahead and deploy our worker agent. So I'm just going to copy this Docker compose YAML, and we're going to deploy on Phala Cloud, which is one of our partners for based agents. And we're just going to go down here and create an instance. So while that's booting up, we'll just walk through a couple of things. So this is the Docker image hash, and that's basically going to tell us that this is the code that's running inside of our T. We'll get to that in a sec. But the first thing the T is going to do is basically derive a near account by creating some randomness, and then it's also going to pull a random key from the hardware KMS in the trusted execution environment, and then it's going to combine those two pieces of entropy to basically create a hash that will become the basis for a near key. And then this key is stored in an in-memory key store only, and it's basically running inside a T, so it can't be exfiltrated or taken out. Now, if the T goes offline, we will lose this key, but the way that we have worker agents coming back into the contract to continue on with work if they go offline, or if somebody stops running the T and somebody needs to run another worker agent, we do that all based on the code hash. So let's take a look at how an agent is registered. So basically, we get a bunch of the info from the T environment, and one of those variables I described to you is the code hash. So it's the code hash of the code that you're looking at right now. So it can't really be changed or manipulated in any way because this is the code that you're deploying. And then basically down here, we're going to register the worker with the remote attestation quote, so you know it's running inside a T. This is the collateral that came from the PCCS URL, this Intel thing, to basically verify the remote attestation. And then there's a checksum for Phala's attestation explorer, so you can take a look at the attestation on Phala as well. And then, like I mentioned before, it's the code hash of the code that you're looking at right now. So by now, we definitely should be deployed on Phala Cloud. So yeah, let's go ahead and look at our based agent here. We can run the logs by going to containers, and we can view the logs, so that'll just pop that up. So it's a Next.js app, it's started, it's booted up, and we're gonna go and we're gonna visit it now. So the agent account has been created, so we're just gonna copy that address. And one thing we'll need to do is we'll need to send some near to that worker agent. So in this case, I'm just gonna send it one near. This worker agent's just running on testnet right now. So I'm gonna go ahead and confirm that, and that will fund that agent. So let's go take a look. Okay, so the agent now has funds. It's got enough balance here. And then the worker contract, which I've called, which just has an account name here, decap magical part testnet. We'll go look at it on the Explorer later. This will allow us to register the agent. So like I said before, and I showed in the code, it's going to take the quote, the remote attestation quote, it's going to take the checksum for Phala's attestation explorer, and it's also going to take the code hash, and it's going to register the worker inside a near contract. So we're just going to go ahead and do that now, and it's registered. We can take a look at that on the Explorer. You can see a few seconds ago, a register worker was called. So let's jump back here and let's get the worker info. So we can see when we call get worker, and this is from our worker's account ID here, we get the checksum. This is for Phala Cloud, so we can view it on the Attestation Explorer. I won't do that on this video, but we also get the code hash. So this is the code hash for the Docker image. So we can go to Docker Hub and we can check this image. We can pull the image into our local development environment. We can ls and cat and look at all the code and stuff of this Docker image to see that the code is what I was showing you earlier here. this code with derive and register worker. So we can verify it basically. Now we can do the exciting thing. We can call a protected method. So what we're going to do is we're going to take the code hash from our T environment, and we're going to call the smart contract, providing it with the code hash, but also we're signing the method from this account. And what it's going to do is it's going to look up in the contract, is this account a registered worker? And if it is, it's going to get the code hash that we submitted when we registered the worker, and it's going to compare it to the code hash that we're purporting to be able to have access to. So it's a method protected basically by this particular code hash. And it looks like it's verified as true. So I'm going to go ahead and I'm going to jump to the contract and show you what that looks like here. So we came down here, we registered the worker, we passed in all of this information and our code hash, and basically we inserted a worker here with the checksum and the code hash, and we inserted it based on our key or our near account basically. So the near account ID is sort of like the lookup to the worker. And then here in the, what we called is verified by code hash. So we provided a code hash, and what we did was we called self require worker. So basically we had to require that there was a worker that existed from the predecessor, the person calling this method. And then basically that worker code hash needed to equal the code hash that we said we wanted to check we were verified for. So this is a way for workers to kind of just self-check that they have access to methods and stuff. And if all is good, then the agent abides and we're okay. So that's about it. Just wanted to give a shout out to Phala, because a big part of the step here is getting the verified report from the remote attestation quote and collateral. And that was made possible by Phala's repo here, decap_qval. And we basically were able to run this inside a smart contract. So yeah, that's the demo, and that's the agent running in here, and it's pretty cool. Now from here, a lot of things are possible. You can basically approve a code hash as an owner. So there's a couple other example methods here. Approve code hash if you're the owner of the contract. Now, obviously, you wouldn't want just the dev continuing to approve code hashes and upgrades. So you'd probably want a more robust method for updating approved code hashes here, so that like users had a cooldown and a chance to kind of deal with funds and things like that. But you also could just approve multiple code hashes, and then here's a function that basically searches for, or it gets the worker, and then it makes sure that the worker's code hash is included in the approved code hashes. So there's multiple different ways you could go about this. The designs are all up to you, but basically what we've shown is that we can deploy an agent in a trusted execution environment. It can contain arbitrary, JavaScript, Python, whatever. Then that agent can be registered inside a smart contract. And then from there, we can basically restrict the methods in that smart contract that the agent can call, provided that the agent was registered from a particular code hash with a particular account. Now the account is ephemeral, and that the agent can go offline, but anyone can boot up an agent at any time. So there's no real availability issue here. Anyone can boot up an agent again at any time, provided that they're using the same Docker image, and that agent can register itself in the contract and continue on with the work and continue kind of, I guess, pushing the state forward and making kind of progress in the protocol. So that is the based agent stack. Thanks for taking a look, and look forward to seeing what people would build.